Hello. Today I will do a basic presentation when it comes to patching programs or executables. A program is essentially made up of two things, opcode and data. We can change either one of these two to alter a program's behavior. In this tutorial, we will go over altering the data in a simple program. So here, this is a simple program that just asks us for the user for their name. It prints it out, but it also creates an evil version of a user's name. Here I just hard-coded the evil version of my name. Now let's see if we can alter it to print out something else in Visual Studio 2022. Now I did set a breakpoint here to stop execution at the beginning of the function. Now let's start the debugger. Now here we are. Now let's look at the disassembly. Now what's happening here? Now because this is uninitialized data, the disassembly essentially kind of skips it and waits for it to be called upon when it's filled with user data. Now what do we do here? It looks like we're moving 4 bytes from this address into EAX and then moving those 4 bytes into this address. Let's remove the symbol name so we can get a better idea of what we're looking at. So it looks like it takes 4 bytes from this address. Now let's see what's at that address. 7B30. Now it looks like that's our first string, Evil Luis. If you remember, that was the string that was hard-coded. Now because this is a 32-bit program, move is limited to 4 bytes. So it looks like we move 4 bytes, which would be these, which would be the evil part, into EAX, and then we store it to our local stack pointer, which is EBP minus 28 hex. Now let's step into that and see if that's what's written there. Okay, now we move those 4 bytes into EAX. And now if we go to EBP minus 28 hex, we should get those first 4 bytes. Here, evil. Now it looks like we do the same here. Let's go through those. 1, 2. Now we're at this line. Here we can see highlighted in red the next 2 bytes. Now because I programmed the buffer to be 10 bytes long, and this string is only 8 bytes plus the null terminator, the compiler will fill in the rest of the empty buffer with null terminators. Now we can see it does that here. It goes to this address and it stores a single byte into DL, which is a lower register, and it stores it at 20. Now let's see what happens there. You can see it stores one null terminator, and then it zeroes out EAX and fills in the last space with another null terminator. We can see that happen. Good. Now we get user's input with scanf. Now here it looks like we're gonna take this effective address, which would be EBP minus 14, and that would be minus 14 hex. It looks like we're storing this address into EAX and pushing it to the stack. It then looks like we're gonna push something from this place in memory. Let's see what's stored there. 6, 3, 7B, 3C, 8, 3C. It looks like that is the string format code for scanf. Yep, that looks like what it is, which would make sense because we are taking a string from the user, and then we call some function. Given that we have these two parameters, we can guess that this is most likely a scanf, but we can also confirm that by just looking at the source code. Now it looks like we call scanf, and then scanf will do its thing, and presumably here is where we will have the pointer to our user given string. Now let's step over that call. No, oh, well, it's asking us to input something, so let's just put Luis. Okay, now let's go to EBP minus 14 and confirm that. Now it looks actually like it stored the string itself, which I guess would make sense because in the program, we created in a buffer array. We did not create like a pointer to some place to store the string. All right, now that we have the user string, we can go into altering what's printed. So let's step into that first print statement. So it looks like we're getting the address that EBP minus 14 hex, which stores the user given string, which is Luis with the null terminator. Now at this point, we can step once. So now EBP has that, AEAX has that address of EBP minus 14. What we can do in this hex editor that Visual Studio has is alter the bytes. So if we want to change this to 4D, it says Mois, or maybe 7.5. So it says Mui. Now, this has been changed in the program's memory. So this push doesn't care what's actually there. This is just pushing this address to the stack. Now let's step into that. And then here, what is being stored here? Because this is a print statement with this initial string, we can assume that at this location is this. We can confirm that by looking in memory. 637040. And we can see that there with the string format code and the 1 plus 1 point hello is there. So it looks like that's what, if we didn't have the source code, we would be able to assume that this is likely a print statement. Now, because we did change what was in memory for the address EBP minus 14 hex, we can assume that the print statement will now say print Luis. Let's see what it says. Let's go over that print and let's see. Look, it says hello mu. Now let's try it with the evil name. Remember, we stored the beginning of the evil name at EBP minus 28 hex. Let's see what's there. Now, one thing to note is that when you're altering the data in a program, a running program that is, make sure to look in the memory itself, because most of this stack frame is filled with empty C's, which don't really mean anything or isn't important to the program execution. We can essentially make the string as long as we want. So here, let me replace these two null terminators with something like 45 again. 45, 45, 45, 45, 45, and make sure to null terminate it. Now let us step into this Li queue, or this Li. So it loads this address into EAX, pushes that address, and then it pushes presumably this string address. So we already know what's there, so we can just go to the call, and now we know that this is going to print this evil Luis plus these 5 E's. That is a null terminated string. Now let's step over that and see what printed out. So we can see, now we can see here that with by altering the memory of the program in main memory, we're able to alter how the program functions. Now this is just a simple basic program that prints out strings, but we could use that in different cases. Say you have a program that asks for a password in, let's say, like a CTF, the flags behind a password, a protected login screen. You could run the program in a debugger, and then either, you could do this in 2 ways. You could either look at what the string is being compared to and alter that in memory, alter your string in memory to match the string that's stored in the program, or you could change the opcode to be from a jump if equal to a jump unconditional. But in this case, this is just to show how the basics of patching a binary works and altering it to do what you want. Thank you for watching, and if you like this, check out my links, my LinkedIn and my GitHub.